This is an instructional video on identifying rational and irrational numbers. So we're going to start with rational numbers. Rational numbers have many different types. The first type is that it can be a whole number. Okay? Whole numbers are numbers that we're used to seeing. It could be a positive whole number like 5. It could be a negative whole number like 3, and it does include 0. So positive, negative, and zeros are all rational numbers. All fractions are rational numbers. That includes positive fractions like 1/2, negative fractions like 3/4, improper fractions like 8/7, and mixed numbers like 1 3/5. All fractions are rational. Our perfect squares are also rational. The ones that we learned, the square root of 25, we know that the square root of 25 is 5. 5 is a whole number. It's rational. Square roots, perfect square roots, are rational. Our perfect cube roots are also rational. For example, the cubed root of 64. We know the cubed root of 64 is 4. 4 is a whole number. It's rational. Cubed root of 64 is a perfect cube. It is rational. Decimals that stop. Decimals that stop, that would be like 3.5. There's only one decimal. It does not continue on. Another example, negative 6.25. It stops. It does not continue on. It doesn't repeat. It doesn't go on and on. It just stops. Decimals that repeat are also rational. So for example, 1.6 repeating, typically the repeating decimals have the line on top. They are rational. Even if they don't have the line on top, negative 3.12, 1, 2, 1, 2, 1, 2, on and on and on, and they'll have these dots out to the end, it is still repeating the same pattern, 1, 2, 1, 2, and so it is also rational. Now, for our irrational numbers. The first type of irrational number are symbols. Any mathematical symbol. The most common symbols you will see are pi, and sometimes you'll see the letter E. Both of those represent irrational numbers. We can say non-perfect squares, so square roots that are not on our list of 15. For example, the square root of 37. 37 is not on our list. The same rule applies for our non-perfect cubes. Any of the cube roots that are not on our list. For example, the cubed root of 12 is not on our list of 5. It is an irrational number. And the last type of irrational number are decimals that do not repeat. For example, 3.15967, on and on and on. Those dots mean it continues on, but there is no pattern to that number. It does not repeat. Couple of quick notes. If you are ever unsure, always guess rational. If you're ever unsure, always guess rational. Most numbers are rational, so guess rational. The toughest problem is the decimals. So make sure you're looking, does it stop? Does it repeat? Does it continue on? Remember, if it does not repeat, it is irrational. Decimals that stop, decimals that repeat are rational numbers.